something like that. Not the greatest, but you get the idea, right? It's an amplitude modulated signal. We're in that signal, it's going to contain the 27 megahertz carrier. It's also going to contain plus 500, right, hertz. So what's that? That's going to be 27,005. Okay, and then it's going to be minus 500 megahertz, right? So that's going to be, on one side, it's going to be 26, 9, and 5, right? Yeah, that should be right. 995. Okay, so at certain points we're going to be so 500 hertz up, 500 hertz down. Okay, so we have, and this would be the lower sideband, this would be the upper sideband. Okay, and again, we can calculate how much modulation it is based on the potential V2, right? So depending what it was, like we saw on the last slide. So that's this entire signal. Now, I asked the question, if we have 100% modulation, so at 100% modulation, I will have, maybe I should have made that a little bit more clear when I presented it as this guy. Oops, there you go. As this guy. Sorry, just to be clear, when I talked about the carrier frequency being the upper and lower sidebands being a quarter of the carrier, that is only at 100% modulation. Okay, so that's only at 100%. Otherwise, the powers, there's a different ratio that exists with that. And there's ways to calculate that. It's in your book, but for our purposes, as technicians, not required. Okay, so what you need to know is that 100% modulation, you will have 6 dB loss on the upper and lower sidebands. Okay, so now moving on from this, what we have is our signals and everything is created. So now that is pretty much transmission in a nutshell. Okay, creating the amplitude modulated signal and then propagating it into space. So now our signal is gone. It's off. It's into space. Now what we have is a receiving end of things. Okay, and then this is just a simple depiction of what the receiver does. So what the receiver does now, first things first, our antenna is going to pick it up. And our antenna picks up everything. Okay, so we got a nice little antenna here, right? And he's going in here. Oftentimes, what we're going to find at the beginning of the antenna is some sort of filter. Okay, it's going to be some sort of filtration happening at the very front of it. Okay, and we're going to filter so that whatever we pick up, we try to. This will be the widest filter in the system. When we break down piece by piece what is inside the receiver, this would be the widest filter because we need to include, remember, our upper and lower sidebands. So the first step into extracting this data, right? So the antenna picks it up. This signal, very weak at this point, okay? Very weak. So oftentimes we are going to go through this, and I'll talk about the first step, which is the RF amplifier. We oftentimes amplify the signal first, and then we start extracting and demodulating. But this will serve the purpose to just a simple diode detector. Okay, just to give you an idea what's going on. So what we're going to do first is this is our amplitude modulated thing. We're just going to cut the top portion off. Okay. So when the top portion's off, the resistor, this is just across the resistor. And then we often select our resistor values to have a certain time constant. Okay? When the switch is made, what we're going to allow is the capacitor. Now notice the capacitor is going to start charging, but this guy here, so the capacitor is going to start charging, but as this wave is going up and down, up and down, up and down, the capacitor is never given a chance to discharge. Okay, so again, we carefully select these two for the proper time constant, right? And remember, anytime you have an RC time constant, right? It's whatever that is times 5 is the charge and discharge times. So times 10 total, right? But anyways, so when he sees this guy, he charges, right? But notice the next peak goes a little harder, so that the capacitor charges a little bit more, right? And the capacitor charges a little more on the next peak. He's never really given enough time because of the carrier frequency speed to discharge. So what happens is he charges. Now the signal starts to reduce. Now he's actually starting to discharge a little bit. Okay, now he's actually starting to discharge a little bit. And what we do is at the output of this guy, we get some rough type of intelligence extracted. Okay, there's a lot more to what's going on inside the receiver, but this gives you a nice Coles note as to the whole process from what makes up the amplitude modulated signal to transmission all the way to receiving. Okay.